Ever wondered why that first API request to your serverless backend takes seconds to respond while the next one finishes in milliseconds? That painful delay is a cold start, and it is the price we pay for scaling to zero. When your application scales down to zero, the platform destroys its active containers to save resource costs. When a new request arrives, a four-step initialization sprint begins. The platform provisions infrastructure, downloads your code zip, bootstraps the runtime, and runs your app initialization code. Once this life cycle completes, the environment stays alive or warm for a grace period. A subsequent request skips the first three setup steps entirely, hitting the active memory sandbox directly and responding in a fraction of a second. In production, cold starts are triggered by three events: container recycling after an idle timeout, sudden traffic spikes forcing the platform to scale out horizontally, and fresh code deployments that invalidate your active hot environments. The impact of cold starts varies wildly by tech stack. Lightweight JavaScript runtimes or V8 isolates boot in milliseconds, while JVM monoliths can take upwards of 10 seconds to warm up database pools and dependency injectors. We can combat cold starts by writing native GraalVM binaries, keeping containers warm with synthetic ping requests, or paying for provisioned concurrency. But the ultimate cure is keeping deployment package sizes small and lazy loading heavy libraries. If your service runs user facing checkout flows, cold starts are a conversion killer. But for asynchronous queue workers or cron jobs, scaling to zero is an engineering cheat code for zero idle server costs.